Hello, greetings and welcome back to All-in-One Super Coaching. We are now doing chemical reactions, balancing of chemical equations, and different types of chemical reactions and redox reactions. Okay, now let us go to some of the acids, because acids are very important in chemical reactions. The most important inorganic acids are sulfuric acid, number 1, hydrochloric acid, nitric acid, phosphoric acid, and carbonic acid. In these 5 acids, carbonic acid is a very weak acid. The other acids are very strong acids. These strong acids are very much in use in industrial areas, and therefore it is very important to study about the acids. And also we have to know how it is produced, and the same example you can use for answering different questions. And the next chapter is acid and bases. Therefore this study will help you a lot. Let's think about sulfuric acid first. The formula of sulfuric acid is H2 within bracket SO4. SO4 is a radical. You have to put a bracket for that, because it acts as a individual element having its own valency. SO4 have valency 2. Next is HCl. Here you can see Cl is there. Cl valency is 1, H valency is 1. It is 1:1. Therefore HCl. Right. HNO3 is also, NO3 is also a radical. NO3 together you have to write within brackets. But here you see NO3 is also having valency 1. That is why there is no other number. So the valency of H is 1, NO3 is 1. Even in the crisscross method it is 1:1. Therefore it is the formula is HNO3. But when you come H3PO4, PO4 within the bracket is the radical. Its valency is 3. Hydrogen's valency is 1. So when we write the valencies, we write the valency of PO4 near hydrogen 3, and valency of hydrogen near PO4 it is 1. 1 is dropped, therefore H3PO4. Next is carbonic acid, which is a very common acid we drink every day, most of us. It is the soda, the plain soda, the fizzy drinks, any fizzy drinks like Coca-Cola, Coca-Cola, Pepsi, or any other fizzy drinks. Fizzy drinks means that when you open and you can see a lot of bubbles coming out in brisk effervescence. That is carbon dioxide, because this carbon dioxide is dissolved in it by applying a lot of pressure. In it means in water. So when you dissolve this carbon dioxide into water, it will become an acid because of the presence of hydrogen ions. But this is a weak acid. Okay? Let us learn combination reactions. You might have seen sulfur. Sulfur is an yellow powder. You can burn sulfur to produce sulfur dioxide. So this sulfur dioxide, in special conditions, you can make into sulfur trioxide, that is SO3. Sulfur dioxide is SO2, SO3. When this SO3 is dissolved in water, the result is H2SO4. See? And see the balancing, and we will proceed. So that is, and also don't forget one thing, all the inorganic acids are in water, aqueous. Because the acidity, we can call them acid only when they are in a liquid form. Okay. Next is hydrogen reacts with chlorine to make hydrogen chloride gas. When it is a gas, we have to call it as a hydrogen chloride. This hydrogen chloride can be dissolved in water. When it is dissolved in water, we get hypochlorous acid, that is HClO. But this O will escape quickly, and only HCl is left. HCl will be in the form of ion, H plus ion, and chloride minus ion. The presence of H plus ions make it an acid. Therefore, when it is aqueous, it is called hydrochloric acid. When it is gas, we call it as a hydrogen chloride. It's very important, okay? Now, next is nitric acid. NO2 is nitrogen dioxide. by using some method, and nitrogen dioxide is produced. Again, the nitrogen dioxide is dissolved in water, then HNO3 is produced. Here the radical is in bracket is NO3, its valency is 1, and hydrogen valency is also 1. Again PO4, H3PO4, the production line I am not telling because it is not in the syllabus. Then the carbonic acid is produced by dissolving carbon dioxide into water. And while doing, we can check the combination reactions in these. After this, we will go to the decomposition, and